In this lesson, we're going to have a look at Unit 8, Chapter 11, Permutations, Combinations of Binomial Theorem. We're going to continue with combinations, and we're going to look at combinations with restrictions. Okay, let's jump right into this here. Example 1. There are 12 females and 18 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. How many selections are possible if the group consists of 2 females and 3 males? So there's a specific selection here now. He has to have 2 females and 3 males in the group. Notice that there are 18 females to choose from and there are 18 males to choose from. He wants 2 females out of the 12. So if he wants 2 females, it's the C of 12, choose 2. He's choosing 2 of the 12. The order doesn't matter here again. The order in which he chooses those 2 students does not matter. So it's a combination. Times, he has to choose 3 males out of the 18 males. There are 18 males, choose 3. And we do need to multiply these together, simply because for every way of choosing the 2 males, there are this many ways of choosing the 3 females. So we do need to multiply this together here. It's a product. So the C of 12, choose 2. We do that on our calculator again. You should know how to use this on your calculator at this point. So I do 12, press the math key on your TI-83. Go down to C of n, choose R. So we're choosing 2 of the 12, which is 66 ways. And the C of 18, choose 3. So we do 18, go to your math. C of 18, choose 3, is 816 ways. So we get 816 times 66, which is equal to 53856, 53,856. And again, think about the multiplication. For every way of choosing the 3 females, there are 66 ways of choosing the 2 males. That's what we need to multiply them together. For each one of these ways of choosing the 3 females, there are 66 ways of choosing the two males. So it's a product. B part. If one of the female students is named Brooklyn, how many 5-member selections consist of Brooklyn and 1 other female and then 3 other males? So now he wants Brooklyn to be on this committee. So how many ways can he select Brooklyn? There's only one way to do that. How many ways can he select another female? Well, how many females are left? Once he's chosen Brooklyn, now there are only 11 females left and he has to choose one of those 11. He still wants to choose 3 males out of the 18 males that are there. So the answer this time is 1 times the C of 11, choose 1, and the 18, choose 3. C of 11, choose 1 is 11, times 18, choose 3, we just did that, 816. So 816 times 11, which is going to give me 8,976 ways to make the selections. Example 2. In how many ways can a debating club coach select a team from 6 grade 11 students and 7 grade 12 students if the team has to have 4 members, but only 1 of whom is a grade 11? So he wants 1 student from grade 11. The team has 4 members on it. So he needs to choose 1 student from the grade 11 class, which consists of 6 members. So he's choosing 1 of the 6. Now the team has to have 4 members on it. So he has to choose the other 3 members from the grade 12 class, which consists of 7 students. So it's the C of 6, choose 1, which by the way is 6, times the C of 7, choose 3. Do that on my calculator very quickly, which is 35. So 35 times 6 gives me an answer of 210. That's how many ways he can select the 4-member committee or debating club. Example 3. This is a multiple choice. And again, now if you're confident enough with permutations and combinations here, you may want to pause this recording, try this question, and then watch me do it afterwards to see if you have it right. A group of 24 people are in a math league. A 4-person committee is to be formed from within the group. However, 2 of the 24 people in the group must be on the committee, which represents the number of ways this 4-person committee is formed. So there's 24 people in the group. 2 of them got to be on the committee. They're really, really smart in math, and you'll want those 2 people. So he chooses those 2 people. There's only one way of choosing the first person that he wants, and there's one way of choosing the second person that he wants. Now, he needs to choose the other 2 people to make up the 4-member committee. He's choosing those 2 members from the 22 that are left. There are 22 members left to choose, and he needs to choose 2 of those 22. Order doesn't matter here again. This is, again, a combination, because when he chooses these 2 people, the order in which he chooses them doesn't matter. He's still got the same 2 people. So the answer is simply the C of 22 choose 2, which is A. Example 4. A 5-member team must be chosen from a group of 4 men and 6 women. In how many ways can this be done if there is exactly 3 women? Again, you may want to pause the recording here and try this question before I actually do it. Okay, here we go. He has to choose a 5-member team. The team must consist of 3 women. So the team must consist of 3 women, and there are 6 women to choose from. He's going to choose, or the person will choose, 3 of those 6. Now, of course, there's a 5-member team, so he still has to choose 2 more members. The other 2 members must come from the 4 men that are in the group. So my solution is going to be the C of 6 choose 3 times the C of 4 choose 2. Do that on my calculator. The C of 6 choose 3 is 20 times the 4 of choose 2. Do this very quickly here. It's 6. 20 times 6 is 120. There's 120 ways of making this selection. One more example here. A standard deck of cards contains 4 suits: hearts, spades, diamonds, and clubs. And they're all here, as you can see. Here's the hearts, spades, diamonds, and clubs. Each suit consists of 13 cards for a total of 52. Each suit consists of 13 cards: ace through to the 10, jack, king, and queen. So we got 13 cards in each suit. 13 times 4 is a total of 52 cards. How many ways can a hand of 5 cards be dealt that contains the 8 of clubs? So it only contains the 8 of clubs. How many ways can we deal it so that it contains the 8 of clubs? Well, if it contains the 8 of clubs, there's only one way of choosing the 8 of clubs. He has to now choose the other 4 cards must come from the remaining cards. How many cards remain? There are 51 cards remaining. So if it got to contain the 8 of clubs, there's one way of choosing that card. The other 4 cards that are to be dealt must come from the other 51 cards that remain. So I simply do that. Do this on the calculator here. And the answer is 249,900 different ways of dealing 5 cards so that the 8 of clubs is one of those cards. How many ways can 5 cards be dealt if it contains 3 clubs, 1 red card, and 1 spade? Okay, so we need to have 3 clubs here. How many clubs are there in the deck? There are 13 clubs. How many ways can I choose 3 of those 13? That would be the C of 13 choose 3. How many ways can I choose a red card? Well, how many red cards are in the deck? There are 26 red cards in the deck, and I'm going to choose one of those. Times, how many ways can I choose a spade? Well, there are 13 spades in the deck, and I need to choose one of those. So I choose 3 clubs from the 13, I choose 1 red card from the 26, and I choose 1 spade from the 13. Let's see what the product is. I get 286 times, this is 26, this is 13. I already know the answers to those. And my answer is simply 96,668. How many ways can a hand of 5 cards be dealt that contains 3 black cards? Now I did put in and 2 others. I really didn't need to add that in there. I could have just simply said that contains 3 black cards. It's obvious that the other 2 must be red cards. But it must contain 3 black cards. So if it contains 3 black cards, I'm choosing 3 black cards from the 26 black cards that are there. The other 2 cards are not black. So if they're not black, then they got to be red. And there are 26 red cards. So again, we had the C of 26 choose 3 times the C of 26 choose 2. Let's see what that equals. The C of 26 choose 3 is 2600 times the C of 26 choose 2. It's 325. Multiply the 2 together, and we get an answer of 845,000. And that was the last example. So, key idea is very simple. When considering combinations with constraints, you determine the number of combinations for each constraint and you multiply each of them together. And that's exactly what we did in every example that you saw there. That ends this lesson.